solving a less than absolute value inequality. Earlier we took a look at an absolute value equality. Now we're going to be talking about absolute value inequalities. Well, the first one, of course, is going to be less than. And then in a subsequent lecture, we'll talk about the greater thans. Let's start with the standard example. The absolute value of some number x is less than c units. Now you may want to review the definition of absolute value. I'll talk about it here shortly. But notice my c is going to be greater than 0. Well, that's because the absolute value is defined as the distance away from 0. The distance always has to be a positive value. That's why I let c be a positive value. So let's take a look at this. The absolute value of some number x is less than c. Well, if I think in terms of distance, the distance that the number x is away from 0 must be less than c units. Let me go ahead and put the number c here. We'll put the number negative c over here. Again, let's look at this problem. The distance away from 0 must be less than c. So let's see. Could x be out here? Could x be over here? Well, if x was a number over here, notice it would be more than c units away from 0. So x certainly can't be out there. Let's see. Could x be over here? Again, if x was over here, here is c units away from 0. This would make x more than c units away from 0, so x could not be there either. Well, x is going to have to be somewhere in here. Certainly, it could be somewhere in there. Any point in here is going to certainly be less than c units away from 0. So what we have to do is formulate a way to attack that problem. Again, the distance away from 0 is less than c units. So we've got basically two inequalities here. Let's attack this one first. Well, x could be in here. Well, that's just the inequality. X is greater than a negative c. Well, x could also be in here, so I'll say and x is less than c. So there are my two inequalities. Now that's okay, but maybe we can combine these as one inequality. Let's see if I can do it. I know that x must be greater than a negative c, and I also know that x must be less than c. So we obtain that double inequality, sometimes known as triple inequalities. Let's do another example. The absolute value of 2x minus 5 is less than or equal to 7. Again, I'm going to draw a number line. I'll put my point 0. I'll put my 2 points 7 and negative 7. Now, if I think of this in terms of a distance problem, the distance that this number 2x minus 5 is away from 0 must be 7 units or less. So that tells me that 2x minus 5 must be in this interval, and 2x minus 5 could certainly be in that interval. So just like the problem before us, before this one, I put my variable in between negative c and c. I'm going to do the same thing. I know that 2x minus 5 can be greater than negative 7 or equal, and 2x minus 5 can be less than or equal to 7. Now earlier we did a lecture on solving these triple inequalities or double inequalities. Both terms are used. We can simply solve this by adding 5 to each side. And now I can divide by 2. And again, since I'm dividing by a positive value, it's not going to change any of the directions of my inequalities. And I get that solution. Now, what's the interval notation for that? Well, that's just simply going to be -1. It's going to be a closed bracket because of the equal to. All points between -1 and 6, including the endpoints. Okay, let's take a look at that example again, and let's make sure it makes sense to us. 2x minus 5 is less than or equal to 7, and our solution was all the points between -1 and 6. Now, let's just check to see if this is true. Our solution is all points in between -1 and 6, which means we can pick any number in this interval, plug it into this inequality, and it's going to be true. Any number we pick outside of the interval is going to make this thing false. So let's just randomly pick a couple numbers. Let's see. How about this number right here? How about we check the number 5? Let's plug the number 5 into here and just make sure that this is true. 2 times 5 minus 5. Let's see if that is in fact less than or equal to 7. 2 times 5 is 10. 10 minus 5 is 5. And the absolute value of 5 is 5, and certainly that is less than 7. In fact, I can pick any point in this interval, and I'm going to get a true statement. Now let's pick a point outside the interval. Why don't we pick a point here? Maybe -3. Now that should give us a false statement. Plugging in a -3, we want to check to see, is that in fact less than or equal to 7? And we're going to assume that it's false, but we'll make sure. 2 times -3 is -6. -6 minus 5 is -11. The absolute value of a -11 is 11. And notice 11 is definitely not less than or equal to 7, which is definitely false, exactly what we predicted. So again, with this my example here of absolute value of 2x minus 5 less than or equal to 7, my solution is just the numbers in between -1 and 6, including the endpoints, certainly. Let's try one more. Okay. Absolute value of 5 minus 3x less than 14. Again, I think the easiest way to do these is to draw my number line. And I'll try to set up my triple inequality. I know that this number must be less than 14 units away from 0. So my number 5 minus 3x must be in between -14 and 14. So I can quickly set up my problem. 5 minus 3x must be greater than -14. It could be less than 14. And now we'll just solve this inequality. Subtract 5. -19 is less than -3x, which is less than 9. And now divide by -3. 19/3. Notice, I divided by a negative value. That means I'm going to have to switch the direction of my inequality. Again, I divided by a negative, so I'm going to have to switch that one as well. And so there is my solution. Now certainly I can rewrite that. Let's see. I'll rewrite that as -3, and notice my small n, or the less than end, is pointed to the -3. Now I'll rewrite this one. I like to write my inequalities from left to right, from the negative value to the positive value. So my solution in this case is all points in between -3 and 19/3, but not including the endpoints. And if I wanted to write that in interval notation, we just write the interval from -3 to 19/3. Let's summarize. When talking about the absolute value less than, we simply have to remember two things. If the absolute value of some number is less than c, then two things are going to happen. Then this number is going to be less than a positive c, and this number is going to be greater than negative c. And so then we can quickly set up this triple inequality and solve. You might want to practice. Maybe go back and review this lecture a couple times, and then you should get the hang of it.